All right. Guys, these are the characteristics of Hadoop. Open source. So your code can be modified according to current business requirements. Say for example, if you are having any of the requirement that is not getting fulfilled by your Hadoop, current implementation of Hadoop, or any of the things that you want to enhance, change according to your requirement, you can simply download the source code and you can do this. This is quite straightforward. There's no issues. The same issues happen. The same thing happened with my recent project. There I was doing one data crunching project. So in that, actually certain requirement was not getting fulfilled by Hadoop version. So we simply downloaded the source code, tweak it, and compiled and use the same in our code. The next thing is distributed processing. Data is processed perfectly on cluster of nodes in distributed manner. Fault tolerance. We have seen distributed processing in quite detail. Fault tolerance also we have seen in quite detail. So failure of a node or task are recovered automatically by the framework. So if, say for example, if your any of task is breakdown, so that will be rescheduled to some other node. If your node is down, that particular work of that node is scheduled to some other slave. So that's it's the overall framework of Hadoop is very much fault tolerant. Reliability. Now the data is stored quite reliably on the cluster of machine despite of any machine failure. So there won't be any issue of data loss. There won't be any issue of data corruption since multiple copies of data are there. I was waiting for one more question. That means, okay, we are putting 3 copies of the data, okay, for the fault tolerance and high availability and reliability, but isn't it wastage of space? So I would say it won't be wastage. It's if it is providing you these amazing features like high availability, fault tolerance and all. So there is no issue. Everybody can happily accept this. Apart from this, if you have seen, there are majorly 4 components in your the data center, complete data center, your architecture. What are those 4 components, by the way? Can anybody tell me? In your machines, there are 4 major components. In your systems, I'm talking about your machines, local machines only. I'm talking about there are 4 major components in your machines, in your Hadoop cluster. The first is the CPU. Now I think you can tell the rest 3. Not really? Okay. The second is the RAM, memory. The third is the hard disk, and 4 is the network. So out of these 4, the most, I should say the cheapest of all, and that is increasing like anything, the storage space, this the overall capacity is increasing like anything, is for hard disk only. So hard disk spaces are very cheap nowadays. Means when I started, means initially I was having a system of 10 GB quite long ago. Means at that time that 10 GB was a huge gift for me. Means, oh my god, this 10 GB, how will I fulfill this? Now currently I am having 2 hard disk of 1 TB, 2 laptops of 1 TB, 4 TB space I am having here. Apart from that, I am having my this Google Drive and some other storage, cloud storage. Then also I need to clean my data to get the space. Sure, same is case with all of you all. So from 10 GB to this, so hard disk space is actually, I want to say, is quite very cheap nowadays. So it's quite a bit acceptable for all the companies, all the players in enterprise, that if you can store the multiple copies of the data, if you are having getting these amazing features. So apart from this, the critical factor out of this is network. We will come to network again later, since network speed doesn't really increase that much as compared to hard disk. So we have seen about the reliability. Data is quite reliably stored. So we have got, we are getting all these 3 features: fault tolerance, reliability and high availability. So data is highly available and accessible despite any hardware failure. Scalability, let's discuss scalability in a little more detail. So let me go this previous to this. So guys, suppose this is your cluster of 3 nodes. If you want, you can on the fly, like I'm entering a button, I'm pressing a button, the same way you can add more node in your cluster, the same way you can add more node in a cluster. This is called scalability on the fly. This is called horizontal scalability. So you do not need to make your system down, you do not need to perform any complex configurations, anything. You just need to copy paste your current setup from your master or any of your current slave to your new machines, and those machines will now become the part of cluster. That's it. So scalability, if I talk about your Oracle systems, currently recently in my company also we faced some issues. Means the speed of our production system was quite low. It was a 32 core processor. Now we sent a request to increase this, so we make it double 64 core. So the machine went and came in 3 days, and the processor was updated like that. So 3 days our production was down. We need to start a backup production prod 2 for the same. So what I want to say is scalability is not feasible, not possible, if I say on the fly in any other systems. Hadoop runs on a commodity hardware, so it's quite economic. Even if I'd say for the small level to mid-level orgs, they can't purchase a system like 100 core processor, 500, 800 gigs RAM. These sort of machines are really very costly to buy. So surely the top players, top companies can purchase this. So for Hadoop, every company can afford to have that. You can use your normal day-to-day systems also for your Hadoop cluster. Hadoop is quite easy to use. Actually, we do not need to deal with this distributed computing. We do not deal with this fault tolerance. We do not deal with high availability. We do not deal with any of such complex things. Our framework, Hadoop framework, will take care of all the things. Hadoop framework will take care of all the activities. We just need to code. We just need to configure it in a way it wants. That's it. So it's quite easy to use. If you write your own application for parallel processing distributed computing, it's very tough to write that. The next thing is data locality, which is I consider this as one of the most innovative in Hadoop. That's move computation to data instead of data to computation.